Imagine the birth of a star, a spectacle of cosmic proportions. It's a process that unfolds over millions, sometimes billions of years, beginning with a simple cloud of dust and gas. This cloud, known as a nebula, is the very cradle of star formation. Over time, the nebula's own gravity pulls it inward, causing the cloud to collapse under its own weight. As the nebula collapses, the particles within it start to collide, and these collisions generate heat. The center of the nebula, where the heat is most intense, becomes the core. This is the heart of our emerging star, and it's here that a process known as nuclear fusion begins. Nuclear fusion is the powerhouse of a star. It's the process where hydrogen atoms combine to form helium, releasing an immense amount of energy in the process. This energy exerts an outward force, balancing the inward pull of gravity and preventing further collapse. With nuclear fusion underway, our star is now in its infant phase, a stage known as a protostar. For the next few 100,000 to a few million years, the protostar continues to grow by accumulating more and more material from the surrounding nebula. Eventually, the protostar reaches a point where it has gathered enough mass that the pressure and temperature at its core are high enough for sustained nuclear fusion of hydrogen into helium. This is the moment the protostar sheds its cocoon of dust and gas and steps into the cosmic stage as a full-fledged star. The birth of a star is an event of grand scale and unimaginable energy. It's a testament to the dynamic and ever-evolving nature of the universe. So next time when you gaze at the night sky, remember that each twinkling light you see is a result of this incredible process. Thus, from the dust and gas of the cosmos, a star is born. Once born, a star embarks on an incredible journey. A journey that spans billions of years and is governed by a delicate balance of physics. This journey, the life of a star, is a fascinating story of transformation and endurance. At the heart of this journey is the main sequence phase, the longest stage in a star's life. This is when a star shines brightly, fueled by nuclear fusion at its core. During this phase, hydrogen atoms combine to form helium in a process that releases an enormous amount of energy in the form of light and heat. This process is called nuclear fusion, and it's what makes a star shine so brightly. But this isn't a one-way street. While nuclear fusion pushes outward from the core, gravity is simultaneously pulling everything inward, striving to compress the star. This tug-of-war between gravity and nuclear fusion is what keeps a star stable. It's a delicate balance that lasts for billions of years. But as we know, nothing lasts forever. Over time, the star exhausts its hydrogen fuel. When this happens, the balance tips. Without the outward pressure of nuclear fusion to counteract it, gravity starts to win the tug-of-war. This triggers the next phase of a star's life, leading to its expansion and transformation into a red giant. But even in this state, a star continues to shine. It now fuses helium into heavier elements like carbon and oxygen. This phase, however, is shorter, only lasting a few 100 million to a billion years. As the star continues to burn through its fuel, it undergoes further transformations, each phase contributing to the richness and diversity of the universe. Finally, when the star has exhausted all its nuclear fuel, it faces its inevitable demise. The gravity, unopposed, compresses the core while the outer layers are ejected into space, leaving behind a stellar remnant. This could be a white dwarf, a neutron star, or a black hole, depending on the star's initial mass. So unfolds the life of a star, a delicate dance of physics. From its birth in a cloud of dust and gas, through its main sequence phase, its transformation into a red giant, and finally, its demise, a star's life is a testament to the magnificent and enduring power of the universe's fundamental forces. At the heart of a star, a furnace burns with unimaginable heat. Now let's delve a little deeper into this furnace, which is the core of a star. This is where the magic of nuclear fusion takes place, a process that fuels the star and allows it to shine brightly in the sky. Nuclear fusion is the process where hydrogen atoms come together to form helium. This might sound simple, but it's a process that requires incredibly high temperatures and pressures, conditions that can only be found in the core of a star. Under these extreme conditions, hydrogen atoms move so rapidly that they occasionally collide with enough force to overcome their natural repulsion. When this happens, the protons in these atoms fuse together, creating a helium atom. but the helium atom weighs slightly less than the sum of the original hydrogen atoms. The missing mass is converted into energy, according to Einstein's famous equation, E equals mc squared. This energy radiates outward from the core, providing the star with the energy it needs to counteract the force of gravity, trying to pull it inward. It's this delicate balance between gravity and the energy produced by nuclear fusion that determines a star's size and lifespan. But the magic of the star's core doesn't stop with helium. As a star ages, its core becomes hot enough for helium atoms to fuse together, creating heavier elements like carbon and oxygen. This process continues, with heavier and heavier elements being formed, all the way up to iron. These elements are the building blocks of the universe. Every atom in your body, the air you breathe, the ground beneath your feet, they were all once part of a star. Stars are not just beautiful to look at, they are essential to our existence. And so, in the heart of a star, the elements of life are forged. Every star, no matter how bright, must eventually fade. This is not merely an end, but an astonishing transformation, an epic finale to a celestial performance that has spanned billions of years. A star's final act depends on its mass. Less massive stars, like our own sun, swell into red giants. Their outer layers puff up, making them hundreds of times larger. These stars are like aging emperors, their fiery hearts still beating, but their strength waning. Over time, they shed their outer layers, creating a planetary nebula, a breathtaking cosmic spectacle of gas and dust. The core left behind becomes a white dwarf, a dense remnant no larger than Earth. These dwarfs are like the embers of a dying fire, slowly cooling over billions of years, their once brilliant light fading into the cosmic background. But for the most massive stars, their demise is nothing short of cataclysmic. When their nuclear fuel is exhausted, they collapse under their own gravity, triggering a supernova explosion. This explosion is so powerful, it can outshine an entire galaxy, albeit briefly. It's a violent, chaotic end, yet from this destruction comes creation. In the intense heat and pressure of a supernova, elements heavier than iron are forged. Gold, platinum, uranium, all born in the heart of this cosmic crucible. The explosion disperses these elements into space, scattering stardust across the universe. So, while a star's death may appear to be a final bow, it's far from it. This stardust becomes the raw material for new stars, new planets, and even life itself. We are all, in a very literal sense, made of star stuff. In death, a star seeds the universe with the building blocks of new stars, new planets, and perhaps new life. It's a reminder that in the grand cosmic narrative, endings are merely beginnings in disguise. The stars may fade, but their legacy shines on, eternally written in the fabric of the universe. From the ashes of dead stars, new celestial bodies emerge. This profound cycle of cosmic life and death is the universe's way of recycling and repurposing matter. It's a story that begins and ends with stars, the celestial forges that birth and shape the universe. Stars are more than just bright spots in the night sky. They are cosmic factories, churning out the elements necessary for the creation of planets and ultimately life. You see, when a star goes supernova, it explodes, scattering its elements across the universe. These elements, which include carbon, nitrogen, oxygen, and iron, are the building blocks of life as we know it. And these elements don't simply float aimlessly in the void of space. They come together, coalesce, and form new stars, planets, and possibly life. Thus, every atom in our bodies, the air we breathe, the ground beneath our feet, was once part of a star. We are, in essence, made of stardust. This fact underscores the interconnectedness of all things in the universe. We are not separate from the cosmos, but a part of it. We are intimately connected to stars billions of light years away, to the very fabric of the universe itself. The legacy of a star is not just its light or its elements. It is the planets it helps form, the life that may arise on those planets, and the consciousness that may come to understand this profound connection. A star's legacy is found in the stories we tell, the science we discover, and the understanding we gain about our place in the cosmos. Stars in their birth, life, and death mirror our own existence. They are born, they live, they die, and they leave behind a legacy that shapes the universe. And so the legacy of a star lives on in the cosmos and in us. We are a part of that legacy, a testament to the power of stars and a living proof of the interconnectedness of all things in the universe.